Hello everyone, I'm Shivam Pasari and welcome to ASIN Academy. Now, today we will move ahead with the topic permutations and combinations. Now, in the previous lecture, we have discussed some basic concepts, and in this lecture, we shall move ahead with some other properties and rules. If you haven't watched the previous video, then I would recommend you to watch it and then come back for this video for a better explanation. I have also provided the complete documentation of the topics covered in this video, so after watching the video, you can go check that out too. Our first topic for today is permutations of things when some of the objects are identical. Till now, we have discussed the permutations of objects that are distinct. Now, let us find the case when some of them are identical. Let's say I have two red balls and one blue ball. And now, suppose I tell you to arrange these three balls in a row. In this case, we cannot apply the formula of NPR, although we know both the values of N and R, because in this case, we have two identical objects. So, first try out this problem manually, and the cases that I can get is two red balls in the front and one blue ball at the end. Then I can place a red ball, then a blue ball, and then again a red ball. Then I can also have this case, two red balls at the end and one blue ball in the front. Now these three are the only possible cases because I cannot arrange them in any other way. Now this was a problem that you could do manually, but suppose I give you 20 balls, out of which 5 are red, 7 are blue and 8 are green, and I tell you to arrange them. Now arranging them manually is not a good idea, and for these cases we have a formula which goes like this. If you have n objects out of which p are of one kind, q are of another kind and r are of different kind, then I can arrange them linearly in n factorial by p factorial into q factorial into r factorial ways. So I have n objects in total, p of the first kind, q of second kind and r of third kind. So I can arrange them in n factorial by p factorial into q factorial into r factorial ways. Now this was for the three cases that we had. Suppose we had s of fourth kind, then we will divide it by s factorial, and if there are any more, then we will continuously divide it by that. Now we will put a question in this formula. So I had 20 balls, so my n is equal to 20. Then I had 5 red balls, so my p will be 5. I had 7 blue balls, so my q is 7. And I have 8 green balls, so my r is equal to 8. And it doesn't matter that what value you put in PQR, because at the end they will give the same result. And now our answer would be 20 factorial divided by 5 factorial into 8 factorial into 7 factorial. Since you cannot represent this value in either of NPR or NCR form, so you have to simplify this value and get the numerical answer. Now I am leaving this part of simplifying the value to you, and try not to use a calculator because in the exam you will not be given one. You should also practice simplifying these kind of values because in the exam that will help you a lot. Now let's solve another question of this kind. Suppose I am given this word Mississippi, MISSI, SSI, PPI. The question says that find the total number of permutations of all the letters of the word Mississippi. Now these kind of problems are known as word problems, and I will make separate videos on them, but let us first find the answer of this. In these cases what you have to do is first write down all the different letters that are present in the word. So I can see that I have M, I, S and P. For this given word I have only these 4 letters. Now we will find out the length of the word and occurrence of each letter. So as the length of the word N, I have the length equal to 11. Now I will calculate the occurrence of each letter. Now I can see that M occurs only one time, I occurs 4 times, so as S and P occurs 2 times. So going according to the formula, our answer will be 11 factorial divided by the product of the factorials of the occurrence of each letters. So that will be 1 factorial into 4 factorial into 4 factorial into 2 factorial, which is equal to 207,900. Now moving ahead with our second topic, we have circular permutations. Now, till now, we have only solved problems on linear permutations, and arranging something in a circle is completely different from arranging them linearly, and we will find it out how. Now, let us find out the difference between arranging something in a linear manner and something in a circular manner. Suppose I have three people, A, B and C, and I have to find out the total number of ways I can arrange them in a linear bench and then in a circular table. So for the linear case, I know that I can arrange them in 3 factorial ways, but for the case of the circular table, I don't know the value. So let's find out. Let's say I have placed A in this position, B in this position and C in this position. I shift all of them one place each in clockwise direction. So the new arrangement that I will get will be C, A and B. But if you'll notice that going clockwise in both these cases, I will get the answer the same as ABC. So in circular permutations, what we have to do is we have to fix one place and then arrange the rest of the values linearly. Suppose I have to arrange n different objects in a circle, then I will fix one object and I'll arrange the rest n-1 objects linearly in n-1 factorial, and that will be our answer for arranging n objects in a circular way. Now the derivation may seem difficult, but this is a direct case. If you are given n different objects and you have to arrange them in a circle, then you can directly apply the formula of n-1 factorial. Now you will better understand this concept with an example. Suppose you have to arrange 3 boys and 2 girls in a circular table, and in the first case there is no restriction, and in the second case the restriction is that the girls should not sit together. So the first case I can directly write the answer as 5 minus 1 factorial, that is 4 factorial, which is equal to 24. Now moving ahead for the second case, now it says that both the girls should not sit together. And solve this problem by finding out the number of cases in which they will sit together and subtracting them from the total number of cases, that is 24. So let us first find out the number of cases in which they will sit together. So I have 3 boys and 2 girls. So I can take both these girls as a single unit and I will name it as X. Now for arranging these 3 boys and these 2 girls taken as a single unit X, the total number of ways that I will have is 4 minus 1 factorial. Now I will also have another 2 factorial over here because these 2 girls can switch places with each other. I will have 2 cases of G1 and G2 and then G2 and G1. So the answer will be 3 factorial into 2 factorial, that is 12. Now this was the case when both these girls will sit together, and in the question we had to find the cases when both these girls will not sit together. So our final answer will be 24 minus 12, that is equal to 12. Now moving ahead with our concept, we have arrangements around a regular polygon of side K. Now if I am given n different objects and I have to arrange them around this k-sided polygon, so the total number of cases that I will get is n factorial by k. Now this concept is not valid for a rectangle, although for a rectangle we have k equal to 4, and according to the concept we should have the answer as n factorial by 4, but this is not the case. For rectangle we have the answer as n factorial by 2. So if you are given n different objects or n people and you have to arrange them around a rectangular table, the number of cases will be n factorial by 2, where 2 signifies the degree of symmetry of the rectangle. Now this was all for this video, and I hope that you got both the concepts of circular permutations and permutations of identical objects. And don't forget to check out the description box of this video, where I've provided the complete documentation of both the topics with some basic problems for practice. And I hope that you enjoyed today's class, and if you did, then please hit the like button and subscribe to the channel Ace in Academy.